Okay, so here we have another example on how to evaluate the integral using the gamma function. And our task is to prove that integral from 0 to infinity of e raised to x power 3 over root of x dx times integral from 0 to infinity of y raised to power 4 e raised to y power 6 dy equals to pi over 9. So we know the definition of the gamma function, and we need to make this function look like the gamma function so that we can compare. So we'll categorize this question to two. This term here we'll call it I1, and the next term we'll call it I2. And I'll start with I1. So if you check the I1, this one here doesn't fit exactly the definition of the gamma function. So we need to do some few substitutions so that it can look like one. Okay, so let x power 3 equals to t, which will make x equals to t raised to 1 over 3. And then if you differentiate this one, we'll have dx equals to 1 over 3 t raised to negative 2 over 3 dt. And when we check the limit, when x was 0, t equals to x power 3 will also be 0. And when x is infinity, t, which is also equal to x power 3, will also be equal to infinity. So we integrate with the new variable from 0 to infinity, the variable t raised to 1 over 6 e t times dx, and now dx is 1 over 3 t raised to negative 2 over 3 dt. Okay, so we'll do some simplification. The constant 1 over 3 will come out, and then we'll remain with t raised to negative 5 over 6 e negative t dt. Now this one fits the definition of the gamma function. That means we'll have x minus 1 equals to negative 5 over 6. And when we find the x here, we'll have x equals to 1 over 6. Now the whole of this is equal to 1 over 3, which is a constant, gamma of 1 over 6. That's for I1. For I2, we have integral from 0 to infinity, y raised to 4 e raised to y power 6 dy. And again, we'll let y raised to power 6 equals to t, which will make y equals to t raised to 1 over 6. Differentiating this one, we'll get dy equals to 1 over 6 t raised to negative 5 over 6 dt. And when we check the limit, when y equals to 0, t, which is equal to y power 6, will also be 0. And when y is equal to 8, t will also be equals to infinity. Okay, so with the new variable, we'll have the integral from 0 to infinity, I2, t raised to 4 over 6 times dy. And now dy is 1 over 6 t raised to negative 5 over 6 dt. Okay, the little simplification, we'll put together the t and the constants. We'll have 1 over 6 outside as a constant. Integral from 0 to infinity, t raised to negative 1 over 6 e negative t dt. That as well fits the definition of the gamma function. So plugging in the x minus 1, we'll end up having x equals to 5 over 6. Then for I2, we have 1 over 6 gamma of 5 over 6. Okay, now the whole thing will be I equals to I1 times I2, because so then we'll have now 1 over 3 gamma of 1 over 6 times 1 over 6 times gamma of 5 over 6. Putting together the constant, we'll have 1 over 18 gamma of 1 over 6 times gamma of 5 over 6. Okay, so we have this relationship here. We know that gamma of n times gamma of 1 minus n equals to pi over sine of n pi. And in our case, if we take n equals to 1 over 6, now if you check 1 minus n, if n is 1 over 6, will be equals to 5 over 6. Now we can use this relationship. So gamma of 1 over 6 resembles to gamma of n, and gamma of 1 minus n resembles to gamma of 5 over 6. Now the product for this will be equals to pi over sine of, now our n is 1 over 6, so it will be sine of pi over 6. Okay, so we'll have 1 over 18 times pi over sine over pi over 6. Now sine of pi over 6 equals to 1/2. So that means we'll have 1 over 18 times pi over 1/2. And then simplification to this will end up 1 over 18 times 2 pi, which will give us pi over 9, which is what we needed to prove. Thank you.